Good morning, everyone. So, in this presentation, I'm going to talk about all the things you really shouldn't do with your SIP networks. All the things that have gone wrong in our SIP network over the years. I hope some of these things will be something you already know, but hopefully there are things that you do not know, and hopefully I'll save you an incident or two after this presentation. My name is Jonas. I work for a company called Twilio. If you don't know what we do, that's all right. Just remember we do a ton of SIP, which is kind of the most important part of what we do for this audience. I've been at the company for over 7 years. I built most of the voice backend, so a lot of SIPs, obviously. For the past year and a half, I've been doing a lot of video. So SFU was mentioned here. I've been working on that. And the last couple of months I've been working on programmable wireless, which is why you all have SIM cards on your desk. Absolutely nothing with today's topic, but it's more fun than giving out some of the other stuff that we have. So, the agenda is as follows. I'm going to just give a brief high-level overview of our network, just to give you an idea of where I'm coming from, and it's also going to tie into the various incidents that we've had over the years, and these are some of the ones that I'm going to go over. Our network, we're 100% deployed on Amazon. We deployed across 8 different AWS regions. A region is just think of a bunch of data centers. These are the ones where we're deployed around the world. Which ones it is doesn't really matter. Each region has a number of availability zones, and we are deployed in each and every one of those availability zones within a region. Each region looks exactly the same, and this is kind of the high-level overview of how it looks. I'm going to talk more about that in a second. One of the things that's extremely important to us is flexibility. So, we deploy to production, I had to look that up earlier today. In the last 365 days, we deployed 23,793 times to production. So this has to be extremely flexible. Voice-related deploys have been 3,126, and in particular, voice infrastructure, which is essentially what I'm showing here, exactly 1,100 in the last 365 days. So flexibility is a key for us to move forward fast. So each and every one of these elements need to know about their environment. They need to discover each other, and I'll talk more about that because that goes into some of the incidents that we have when they do not discover in the right way. At the end of the day, though, the stack is fairly straightforward. We have a bunch of applications at the end, and nothing special. Some of the apps becomes extremely complex themselves. I'm not really going to go into those. We have a proxy layer, fairly common. All of you guys are SIP guys, so I don't really need to explain what that one does. But for inbound traffic, it selects the application. Outbound traffic, it will select, for instance, if it's an outbound PSTN call, it will select the carrier edge, as we call it. It will select the carriers by talking to our routing engine, and so on and so forth. So nothing in particular. The edge layer, which is an OpenSIPS SIP load balancer. Behind it is just a regular back-to-back UA. Those two together, a lot of people refer to them as SBCs. The key thing for us, and it goes back to my initial statement on being extremely flexible, being able to deploy fast, the edge layer has to be super, super fast, and we keep it extremely simple. So compared to some of you guys' usage of OpenSIPS, we keep ours extremely basic, actually, on purpose, because it sits on the edge, sits behind a public IP, which means it's what's behind our DNS entries. So a lot of the logic for being the border police is actually done by a separate component behind the SIP load balancer, because we can scale that one. And the number of machines we have overall in the company is, I don't know, it's 5,000-6,000 machines or something like that, so it's fairly big. Anyway, as far as the basic functionality of all these components, as I mentioned, they all need to know their environments. They all need to discover each other. They need to know if someone is in service or out of service. And based on that, they will simply just pick a SIP element downstream of it. Nothing special. We all know how this works. Push a route, send the traffic out, and you hit that. So, into some more interesting things. One of the things that we've had over the years are loops of various kinds. Loops can quickly take out your entire network. So, very basic, a bug in a downstream element will potentially create a loop. So, we've had various versions of this where inbound traffic goes through the SIP load balancer, ends up in a back-to-back QA, has had a bug, incorrectly identifies that as an outbound call, sends it back out. That SIP load balancer goes like, oh, hang on, this is an inbound call. And there you go, that's a loop. So apart from don't introduce the bug, a few things that we've done to make sure that this doesn't happen, or at least less likely, is always move forward. So some of the issues that we had is, especially the last one here, do not traverse the same element. So if you have an inbound call, just keep going until you hit the application. So here on your right-hand side, this is kind of what we had once upon a time, it's a couple of years ago. A component in the middle of the flow for an inbound call. It was doing some cleaning up and normalizing on the SIP traffic. First of all, that should happen at the edge, by the way. Don't do that in the middle of the flow. And afterward, it decided to send it back through the same component, and later on, it got it back itself. And the bug there was it tried to do the same cleanup again, and there you go. It's not a fun thing. So in general, I would strongly recommend, and this has helped us a lot, keep moving forward until you hit the application. And only after the application is allowed to change direction. How you do that is obviously up to you. We use direction headers, like I said, only the applications at the bottom is allowed to actually change direction. And don't proxy it in that case. We're going to use back-to-back QAs to have a completely separate leg. This is fairly obvious, but use max forwards. We haven't had this bug, but I've seen another bug coming in from a carrier where they were setting the max forwards. So that loop kind of never really ended, which was a bit problematic. So please just don't mess with max forwards. I think it's probably fairly obvious for everyone here. Another thing that I hope everyone here will probably agree with, don't trust external route headers. Here's another thing that we've seen over the years. People try to push various routes to get by systems. So do not honor route headers you don't know, essentially. That's going to save you a lot of problems, and hopefully loops. Sounds familiar?
Oh, no, sorry.
Okay. Somewhat more interesting, though, is handling downstream issues. So in general, if you're going to contact a downstream element, but that downstream element is having some kind of issue, whatever it is, it's having a bad day, something went wrong, it's a bug. You kind of need to handle that, otherwise you don't have a robust system. So whether it's a timeout or some kind of 500 from a downstream element, you kind of want to select the next guy and hopefully that downstream element can take over. Fairly basic, right? Here's the problem though. Let's say the reason you got back that 500, let's say, was there was actually a common downstream resource that's actually the culprit. It can be a lot of things, databases of some kind, some other service. Let's say in this case, it's a database, right? So this element right here got the first request, couldn't contact the database for whatever reason, network issues, database is down. Generated 500, this upstream element just selected the next guy and hits the same database. So now what? Is that a good strategy? What would happen in these cases? Well, you're not going to make things better. So let's say the database is actually busy. You have some bad queries, some slow queries, you're hitting some indices that you didn't think about, or rather, some indices doesn't exist. So now what you're going to do is make things worse, right? So we usually do two failovers, so it's 3 requests. So it's a perfect attack scenario if someone figures this out. They can slow down your database, and then you know that you're going to help them by amplifying your own traffic. So you're going to slam that database even more, so it's going to be super, super hard to recover, right? So failing over has to be done with care. So one strategy that we have adopted is only fail over on certain error codes. And the assumption or the theory that we have is the node closest to the problem actually knows best whether or not there's any point of even trying somewhere else. So if you're the person talking to the database, hopefully you know why it's not working. It's not always the case. But if you can't reach it, let's say it's a network issue. If you can't reach it, and you exhausted all your available ways of reaching it, then tell the upstream element, like, hey, listen, there's just no point of you failing over to someone else. Because that someone else is still the same request. It's probably going to hit the exact same database, and then you have the same problem. So what we do internally is we only fail over on these error codes. So if the upstream element gets a 408, we assume the downstream is just having a bad day, network issue, whatever it is, and we fail over, or explicit 503s. So if this guy determines that this database is down, send, for instance, a 500, and then we assume you did everything in your power to remedy the situation, but you've given up. And that will prevent things like I showed in the previous slide. If the database is actually slow because of bad queries, you're not going to make the situation worse by just slamming it even more. That makes sense? All right. I'm going to assume that's a yes. There are some bad things with this approach, though. So let's say in this case, the real reason why you couldn't reach the database is because this guy is having some kind of network event. You could argue that maybe the traffic couldn't get there in the first place, which is a fair argument. But let's say it did, and then this one actually has some kind of network event which makes it not being able to reach the database. In that case, it would actually have helped to fail over, right? And you would have reached the database and you would have saved the situation. At least in our experience, it's very hard to detect whether or not it's a network event that's isolated just to that node or those nodes. And based on that, fail over. So we don't do this, we live with this drawback, and then we rely on other systems to measure traffic between nodes and try to detect whether or not something network traffic-wise seems to go down, and perhaps an entire cluster of nodes is having issues, and we evacuate them all. But we don't mess with the SIP traffic, so to speak. We will actually fail that call in that case. But in our experience, it's more robust for the holistic view. All right. So, Eric was talking about registration. I'm going to talk from a slightly different point, and tying all of these tiny issues that we just saw into a massive incident we had a couple of years ago. It kind of goes to some of what Eric discussed earlier, but we'll see. So, first of all, thank you, Eric, for introducing a flow, so I don't think I need to introduce it. But essentially, it's a bidirectional communication pipe, right? If it's a TCP connection, flow is kind of equal to that of a connection. The RFC to read is 5626 if you want to know everything about it. But essentially, I'm going to be mentioning a flow a lot here. So, again, Eric kind of mentioned this as well, so I'm going to save a couple of minutes. But registration, what are we really trying to achieve here, just to repeat some? At the end of the day, what we're trying to achieve is to maintain this flow between the client and you, right? That's what we're trying to maintain. The client will establish some kind of flow, TCP connection, whatever it is, and we need to maintain that, right? So this blue one is the registration flow. At the end of the day, it comes in through our SIP load balancer. It will push a path header. Eventually, we will store it in some kind of database of some sort to remember it later on. And then, of course, Alice here is the one calling Bob, because that's the case. So these blue ones shows the inbound flow. The key here is obviously this is our business logic. We will look up in the location service, get the binding, we get the path header, which is pushed as a route, right? And then it goes out through the right SIP load balancer where the flow lives, which is the key here. So typically, though, at least that's always the case in Twilio, we're a MySQL heavy shop. We also actually have a lot of Cassandra. But in this case, this was MySQL, so we have a primary, we've got a bunch of replicas. In general, we always write to the primary, and you should, in 99% of the cases, read from the replicas. If someone want to debate that later on, we can do that. So, of course, when you refresh the binding, install the binding, you write to the primary, and later on, when the invite comes in here, that business logic will read from the replicas. Makes sense, right? What happens if the primary goes down, or the master, depending what you call it? So, a registration flow, which is the blue dot here, registration will what? Well, it will fail, right? Because the database is down, or the master is down. But calling this client will potentially succeed. Depends whether or not the registration is still active or not, right? So, this is the incident we had. And also multiple things that went wrong. So, hopefully this will save you an incident. But essentially what happened was, we got the client here that tried to install a binding, so it registers, the database was down. First error is, which is what I just mentioned, we did not detect that particular use case. The database was kind of up, but not really behaving. So the error that we got back, we did not handle. So that became a 503, which is what I mentioned 2 slides ago, something we failed over on. So that guy failed over, slammed the same database, because it's the master, and it just made this guy even sadder, right? So it was just getting slower and slower and slower. And as I mentioned before, this is 2 retries, so it's 3 times we slammed the same database. So now we're increasing our traffic, plus this was actually in 2 layers, so it's actually 3 times 3, because of that stupid 503 we didn't catch. So now 1 invite or 1 register in got multiplied to 9, right? So not good. We magnified the same traffic 9 times because of this let's fail over logic, because of that one. So that didn't help. Then this client freaked out. And this is actually our client. So at Twilio, we only build developer APIs and SDKs. We don't ship end-user software. So our client SDK, that one just said, no, I'm not having it. I'm going to start over, and just restarted the stack. Obviously, it didn't shut down the entire app, but it killed the connection, tried to set up a new connection, which worked, because there was nothing wrong with the edge, and then tried to register again. And then that failed, so 27 registrations in our network later, it got back to 500 and go like, oh my God, I got to start over. So now you have and that's TLS for us, so you have the TLS connection to being set up and so on and so forth. So a couple of minutes, and then our entire client infrastructure was out of commission. And we couldn't get these to start, because these are out in the wild. So what I had to do was I firewalled off all load balancers, had to rescue that guy. Once that one was up, I could start letting traffic on again. Right? So just because of a few mistakes here, it just led to an impossible situation. We could not save it without shutting down everything. So what did we do? Just don't panic. That's it. So in this case, in the previous registration will fill in the blank. Well, it depends what the client is up to. If the client already had a valid registration in the database, there was nothing wrong with this node, so that TCP connection is indeed established and working, right? The information of this flow had been replicated, so all outbound traffic was fine if you just didn't panic, right? So now, if the registration fails, let's say it's a refresh, and you install it with a long enough expiration, but you refresh more frequently, now all of a sudden you have a buffer. So what we did, and this was actually iOS and Android, we, for various reasons of how the old VoIP socket worked, which doesn't really exist anymore, 33 minutes, because you could only wake up every 11 minutes on iOS, or maybe we did 35. But that gives us 3 times to retry before it's too late. So if you manage to install the registration once, you got an active binding, next time you're trying to refresh it, you get this error, just don't panic. Everything is working from an end user perspective, right? So the end user doesn't need to know anything. Just like, oh, maybe next time it will be fine. And remember, you can still place outbound calls. Outbound calls has nothing to do with the registration being active or not. You're the one initiating. You could use a different connection if you want to. And inbound was still working to you, right? Because your flow was there. So don't panic. Of course, eventually, if it's not back up in 30 minutes, but if it's not back up in 30 minutes, I have no job anyway, so I don't really care. So, but essentially, don't panic was the fix. Obviously, if you just came online and tried to install the registration for the first time, you would fail. So essentially, this created the perfect registration flood. Again, you will create the perfect DDoS system or attack on yourself with our own code, which is the embarrassing part, right? So what we do, and we kind of, we're a bit lucky here in this particular case, it was our client, so we can get that one to do whatever we want. We don't necessarily care too much about specifications here, because we are the ones talking to ourselves. On our public-facing SIP endpoints, we obviously have to play along with what the spec says, but at the end of the day, the client has to play along, implement backoffs if you can't actually install the connection, server-side, throttle, all of these things that are fairly standard. One thing that we do that's not standard, we move TLS connections around when we deploy. So we ask the client by sending them 302, next time that we register, we're okay, can you move? So I need this machine. So some of those things are not standard, but we can do that because we own a client. For iOS and Android now, we actually don't use registration at all. We only use push notification 100% of the time. Anyway, any questions so far on things you should not do? So a few words about living in the cloud. So as I mentioned, we're 100% based in Amazon. How many of you here are based in some kind of cloud environment 100% of the time? So a couple. Azure, AWS, Google Cloud. Yeah, I said everything. I assume yes to all of this. So this kind of applies to all of those environments. They actually use the same terms as well. So in AWS, which I know the best, you have regions and you have availability zones. So each region consists of a bunch of availability zones. This is true both for Azure and Google Cloud. An availability zone in Amazon's case is essentially a physical data center. That could actually be a couple of buildings, but they're all super close to each other. They have their own backbone, and if you're going to cut the cable, you have to drive in between their buildings and start digging. Right? A region consists of multiple availability zones. In Amazon's case, they can be several kilometers apart, but they all have their own fiber and backbone, so everything is super close. In general, in all of these environments, if you live in a cloud environment, you should absolutely, 100% of the time, deploy in every availability zone that you have in that region. So in our case, this is what our the top level SIP infrastructure looks like. So in any given region, we always have one SIP load balancer for that region behind a public IP. We have a bunch of back-to-back UAs for that border police that I mentioned before, a bunch of proxies and a bunch of apps. They all look the same, so let's say there are 4 availability zones within one region. Then apart from the SIP load balancers, which will be 4, everything else are multiples of 4, because they are deployed evenly across all availability zones. So that's my recommendation, number 1. Make sure you deploy in every availability zone and have equal number of machines everywhere. Number 2, as I mentioned before, an availability zone is essentially one physical building. So you kind of want to stay within that building if you can. So in this case, if traffic hits this guy from the carrier, this SIP load balancer should favor, when it tries to find which downstream element to use, should favor back-to-back UAs in its own data center, its own availability zone. So stay in the same availability zone as much as you can. So AZ affinity, essentially. Then, also realize that things aren't perfect. Availability zones on Amazon, I would say there is a kind of network event between availability zones. If you're AZ affinity, you're usually fine, but remember we have, for instance, databases. and the masters you can't really replicate even if you're sure, but you're going to have to jump borders at some point because of shared resources. So you should really, we haven't actually done this, but you should really automatically fail over or evacuate an availability zone. We have a big button, but we still take a manual decision based on a bunch of inputs because we think it's still kind of scary. It shouldn't be scary because you should practice it. We should have like a big button that just says no, and just take all of these out, move that elastic IP in the world of Amazon to the public IP. We have a hot standby in every availability zone for these reasons. So we move traffic away, and then if need be, depending on the time of day, we put an equal capacity of what we just lost in the other threes, let's say. So please make sure you have that big red button that says evacuate. And then you will have a green button that says bring it back. So it goes with the instance. So, I would say, in our experience, what do you say, Jan? This is my colleague, Jan. Issues between availability zones, maybe once a year. You cannot typically end up reading it on the news. Issues within an availability zone, in my almost 8 years, I've seen it maybe twice. And it always feels like someone tripped on the network cable. Because it's like part of it isn't quite working, and then it turns out that some of them are like these 10 machines, and we email them and go, and it turns out that we're in the same rack. So it feels like someone tripped on a cable or poured a coffee down the switch. But it happens extremely rare, so which is why if you stay in an availability zone, most of the time you'll be fine. And this, I believe, is true for Azure and Google Cloud as well, even though I'm not as familiar with how they set everything up. Make sense? I mean, at the end, especially when we have our postmortems, all of these learnings are fairly obvious when you think about them. But yeah. But at 3 a.m., they're usually not that obvious. So at 3 a.m. is what I use all the time to remind us all our developers that what do you need to do and what information do you need at 3 a.m. when the pager goes off and your brain isn't working. All right? So what we do, and this is another public announcement, just monitor everything. So since this is an OpenSIPS conference, in OpenSIPS we log all requests, and I'm really curious. We looked at Homer a long time ago, but I'm looking forward to the presentation later on. But we log everything we do in a very parsable, friendly way, and we pub that. In our case right now is the Datadog. I don't know if you know what it is, it doesn't really matter, but you can push statistics, and they have actually very, very beautiful and useful graphical representation of that data. So use dashboards. One of the problems that we had like no, when I started we had no statistics, and then we got a mandate like, oh, you need statistics. So we added statistics, and at 3 a.m. no one knew how to read them. It's like just a bunch of numbers and no one understood how they were correlated. So be a little careful what you pub, have a purpose when you actually pub statistics. Another thing we do is we capture everything. So we run T-Shark on every machine. We used to run VoIP Monitor. Now we kind of rewritten everything, so it's not quite VoIP Monitor anymore. We push things to S3. We use Elasticsearch for slice and dice. This is like the post-mortem time when you don't know what actually happened. Elasticsearch is super useful for kind of confirming some hypothesis you have of what went wrong. We've got a bunch of tools for downloading and parsing PCAPs. We use Packets.io, and I'm going to put that one out because I wrote it, so I want people to use it. And also, and I thought I'll show you this one real quick. As a customer, and this is a phone call. Can you guys see? It's a little. This is a phone call I had with my dad. Don't call him, but the number is there. Well, we actually give this information to customers. It's all the same stuff that we've been using for years internally, but we made this available to customers as well, which is really, really helpful. In this case, I was a customer, and then towards the end of the call, my dad complained about the audio quality. So I went in and looked at this call. This one is the RTP stream coming from the carrier. It looks kind of boring because it looks perfect. Everything sounded great in my case, so that kind of makes sense. But towards the end here, you see a slight uptick in the stream going to the carrier. And I was kind of wondering what that was. There was nothing really here that said why that was. I think this is a rendering bug. But looking at the stream from my side, and I was the one on SIP, You see the same thing. This is the incoming stream from the SIP endpoint. So that was my client. I was at home. You can see the kind of the same increase in jitter. But here is what the real problem is. All of a sudden I have 10% packet loss, which obviously translated to jitter eventually later on. But these tools are super nice to have at 3 a.m. in the morning. At 3 a.m. we usually don't look at individual calls, but this is for end customers. It's really helpful for them. They go in, they can see what's happening. In this case, because the flow, if you will, the packet loss came from my client, if I'm a customer of Twilio, let's say, I can go in and see here, I was like, oh, it's probably my ISP, which in my case is often the case. Because I'm pretty sure there's nothing on my home network that causes this, I would like to say. So, again, capture everything, make it available. If you make it available to customers, that's even better. But you will thank yourself at 3 a.m. When you do that. Cool. Anyway, at the end of the day, keep things simple. And that's all I have for this presentation. I'm just about over it. All right. Any questions?
Come on, put them up. What? Listen, you're not on the VIP list. Anyone else have any questions? I know that you can talk to him personally. Who was it? Who had the hand?
I was wondering a bit more about the loop detection you had Twilio.
Come again.
I was wondering a bit more about the loop detection.
Loop detection, yeah.
The question I had specifically was you're especially referring to loop detection within the platform. How do you deal with loop detection outside the platform? So when an external phone forwards a call to another phone which is in your platform, and or maybe directly calling from one endpoint to another endpoint, and therefore bouncing between running through your platform.
The short answer is we don't do a good job. So we get, for instance, we had a really cool incident also a few years ago, where someone did something like that. It was an inbound phone call. They piped it up to their IP PBX. For some reason, they piped it back to PSTN, and they came back into us via, I guess, 2 carriers. In those cases, you know, the typical things you can do to and from, you can see that there's too many calls and things like that. We have some basic things for those types of loop detections, but in general, call me after my next 3 a.m. and then we'll see what the postmortem says. But we don't have a good story there. If you have great ideas, please let me know. Or let Jan know, because I'm no longer on call. I just draw boxes with arrows this day.
Another question, if there are calls, which is a bit of an exception on that, if there is a call from one Twilio number to another Twilio number, is it first passed to PTSN, or is it directly transferred back to your own?
Yeah, we stay internal.
Okay.
Yeah. That's carriers make enough money, I think.
Yeah.
So, but what we have done on the one of the things of staying, and this is another bug we had, which didn't create a loop. But if you have a call that goes back to yourself, because one customer calls another customer, those 2 customers don't know because it's just phone numbers. At some point, we're going to have to loop that around, and it's all of a sudden going to go from this account to that account, billing, blah, 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 all of those things. We had a couple of bugs around that. So what we do is inbound call, the app, outbound call, but instead of a real carrier, we hit, the role is called fake carrier. And then the fake carrier, which is a back-to-back UA, starts over. So all of these machines are none the wiser. It looks exactly like it came from the carrier. So that kind of goes to this concept. Don't turn around in the middle. Anything else?
One more question here from Max. He's there was somebody else. Look at that.
So when you mentioned that you use T-Shark for capturing everything, I'm assuming you don't capture the media, but you capture the stats from the media. And also, when you're capturing it, are you replicating that, are you streaming that to an external service to then capture and put that into Elasticsearch or your Datadog or your external service?
Yeah, so yes to everything kind of you said, even though you had a couple of debates there. But if the customer has audio issues, we will ask the customer, is it okay if we put you on voice trace, upon which we do save the RTP stream? So we can go in and listen and try to analyze. You know, if it's like, it sounds like I'm sitting in a tin can, That's usually something on the far end. We don't typically do transcoding, so, well, it depends, but if we don't manipulate the media, us introducing tin can noise is usually not the case. So we do save it. All statistics around RTP, for instance, always push along with statistics around the SIP traffic itself. We push that to actually Kafka bus, doesn't really matter. We push it to a bus. We have various systems depending on what we do. One system, which is the PSTN Insight system, which will pick up those events and render in a different store for our customers to read from the dashboard that I just showed you. For internal, we push it more raw straight to Elasticsearch, and from there we can do the same slice and dicing that a customer can only do for their particular code. Kind of very high level, but that's kind of how it works. Make sense? Mm-hmm. Yep. And I'm happy to talk more later if you. Okay.
Last question.
Okay, I think I asked it before, but I don't remember the answer.
Wait, you asked it before?
So what are you using as B2BA?
We have written our own. Yeah.
So, thank you.
Cool. All right, thank you guys.